We are in the middle of the Chacao Channel, 1,200 kilometers south of Santiago. We are doing current and turbulent measurements thanks to collaboration with the University of Washington.
There's the crew.
An APL-UW team led by Principal Oceanographer Jim Thompson works with Chilean researchers. Their goal is to learn more about the 8-knot tides that make the Chacao Channel a prime candidate for hydrokinetic energy generation.
Underwater turbines to make electricity. And we're looking for how much turbulence is present in the channel at what stages of the tide to help improve the design conditions for those turbines.
Getting a handle on tidal turbulence is a major challenge.
The measurements are noisy, they have some errors.
Turbulence is the fluctuating part. Those fluctuations require a very precise measurement because there are some additional fluctuations that are just noise in the measurement. They're just instrument error. And so the difficulty for us is getting rid of that instrument error, that contamination, and trying to understand what the true turbulence is. Our key tool is a velocimeter, measures the velocity of water, and it's a very precise instrument, but it can only work right at the local point where it's deployed. Now we'd like to have measurements up above the seabed in the middle of the water column, between the bottom and the surface. To position an instrument there is very difficult. It's easier to just have an instrument on the bottom and just measure the flow on the bottom, or to profile upwards. But those profile measurements are not accurate enough. So instead, what we've done is deployed moorings that put the velocimeter right where we want the measurement. Then we introduce another problem. The mooring moves. The mooring's like a balloon on a windy day. Try to hold on to it, the balloon makes it dance around all over the place. So now we have a very precise measurement, but we have contamination from motion instead of contamination from instrument noise. So now a lot of our post-processing and data analysis is to remove that motion contamination from the data.
Insight into turbulence and its effects in Chile's Chacao Channel can likely be applied to a tidal power project already underway in APL's own backyard.
At Admiralty Inlet near Port Townsend, the project is moving forward and turbines may be installed as early as 2014. And one of the key things in designing those turbines and getting ready for that project has been our measurements of the turbine and helping the turbine engineers understand what to expect in the dynamic loading of those turbines as turbulence comes and goes. The random fluctuations that cause the turbulence are going to cause fluctuations throughout the whole mechanical system of the turbine. That will age the turbine, perhaps prematurely. Those fatigue loads we know are very important in wind turbines. It's likely they'll also be very important in water turbines.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.